Hi guys, today I'll continue to discuss the Giza pyramids and other large pyramids in Egypt. In my last video, I proposed a provocative theory that Egyptian stone pyramids might be mine waste and tailing storage from a previous advanced civilization. I received many comments asking questions on why mine waste piles needed to be so accurately constructed as we see in the King's Chamber, were built with a precise orientation to the cardinal points, and they encoded so many important mathematical numbers. People have put a lot of thought into studying the Great Pyramid and found the alignments and correlations with pi, the golden ratio, the Earth, the Sun, other stars, and more, while they ignore almost all the other pyramids. I believe we shouldn't single just one pyramid out without comparing it with other similar ones. We need to consider and discuss all the big pyramids in Egypt as a group. There must be an intrinsic connection among these impressive structures. Aren't the other pyramids just as mathematically intriguing? Why aren't they getting the same amount of attention? In this video, I'll try to address questions on the precision work, the mathematical aspects, and the star alignments of the Great Pyramid. I will also include information on the other pyramids so we can visualize a bigger picture. Off the bat, let me point out that even though the Great Pyramid is the largest of them all, it might not be the most superior of them all. Its slightly smaller neighbor, the Khafre, is only 3 meters shorter and probably structurally more sophisticated. According to a 2012 published survey done by UK researchers, the size of Khafres are more perfectly perpendicular than those of Khufu's. The Great Pyramid rises at an angle of 51 degrees 50 minutes 24 seconds to the top, and the slope of the Khafre rises at 53 degrees 13 minutes angle, steeper than the Great Pyramid. The Khafre, being a steeper pyramid, still maintains intact casing stones on top. These are the signs of a more advanced construction. Some comments I received mentioned that the Great Pyramid has 8 sides instead of 4 sides. Yes, the Great Pyramid is an 8-sided figure. Each of the pyramid's 4 sides are evenly split from base to tip by very subtle concave indentations. No doubt, the 8-sided Great Pyramid is super impressive. The Khafre, on the other hand, was probably built later with an even higher structural performance, even though it doesn't have 8 sides. Isn't that interesting? Maybe the 8-sided pyramid was not a better design after all. Though, why would the ancients go through all the time and the trouble to build an 8-sided or 4-sided highly accurate waste pile? Anyway, tailings and waste rock are just waste. Slag heaps don't need to be so fancy, right? Well, most people have no idea how important mine waste storage is. Just because the material comes from mine waste doesn't make the waste storage any easier. On the contrary, permanent storage of potentially toxic materials is a huge problem in our world right now. Not too long ago, all the mine waste was dumped directly into rivers and lakes. This had disastrous consequences, but people in the past didn't understand the importance of treating and storing mine waste. The situation is similar to how people today might not realize how necessary it is that waste storage sites be built with accuracy. For permanent large-scale mine waste storage to function well, in-depth mathematical calculations and precise executions are crucial for its structural stability and longevity. Because this is not a sexy topic, we rarely see any media coverage on mines or mine waste, unless it's a disaster. Out of sight, out of mind. Serious topics like the importance of mine waste design to most are boring and not newsworthy. Unless you search for it, you'll likely never encounter an article about it. That's why when we talk about mining waste, such as tailings, some would think it's so insignificant that there is no way the highly precise pyramids would be mine waste storage. Actually, mining is a fundamental part of our civilization with an immense impact on everyone's life. All the metals, minerals, plastics, aggregates, sand, natural gas, and coal come from mining. Our cities, towns, manufacturing, homes, and much, much more are built with all kinds of mined materials. Think about it. Almost everything we own and touch has something to do with mining. Even so, mining is rarely talked about. Mine waste storage is even less popular. We're really taking something crucial for granted. Everything that comes from a physical store or online shopping came from manufacturers which used mined materials. Most of us can hardly imagine the astronomical amount of waste generated from mining and how serious and important mine waste treatment and storage is to our world. The level of care of waste treatment and waste storage is a denominator of the sophistication and progress of a civilized society. If you want to know how developed a country is, we need to check out their stormwater and sewerage systems. Here are some photos of the sewerage systems under major cities. They are designed and constructed with great accuracy because they perform critical roles for the well-being of the cities and the people that inhabit them. Even though they are built as sewers, wouldn't you agree that they look quite magnificent and monumental? They don't have a glamorous name, but the quality of our living environment depends on them. From these sewer systems, we can see that function and beauty can go hand in hand. I think this could be the case for the pyramids as well. They were as functional as they are beautiful. Today in the mining world, dry stack tailing methods are considered the most sustainable and efficient method of physical storage for mine waste. A type of dry stack tailings, the cemented tailings mound technology, is still in the conceptual stage. If the pyramids were actually cemented mine waste storage, it means the ancients were way more technologically sophisticated and environmentally conscious than us. The pyramids were built with great precision, but not all the components of pyramids have the same precision level. The majority of the pyramid blocks, the core stones, are not uniform in size or shape and are only roughly dressed. The precision works we focus on are the exterior casings, the interior chambers, and passageways. I explained in my last video how tightly fit casing stones can work as a rock buttress and impermeable exterior layers similar to rock buttress in the tailings mound design. The casings are very important to prevent water seepage and enhance structural integrity and stability. After all, whoever made such incredible efforts to build the pyramids by putting so much work into piling on millions of tons of blocks wouldn't want the projects to fail, right? The pyramids were built to last, and last they have. These kind of precision stonework can be seen at many megalithic sites around the world, in Middle East, South America, Europe, and Asia. On the Giza Plateau, the Valley Temple was built with giant granite blocks and shares similar features with other megalithic sites. It's obvious that the ancient builders, from a global advanced civilization, had a very high standard of quality. That's the way they did things. They didn't cut corners. Everything they did seemed to show an element of extreme precision and care. It would be difficult for us to achieve the same level of work or alignment, but it might be easier for the ancients. As for the Great Pyramid's almost perfect orientations to the cardinal points, here's a chart of angles of big pyramids at Giza and Dasra. We can see that they're all fairly precisely done within a degree of true north. The two Great Pyramids of Giza, Khufu and Khafre, has the smallest deviation from the cardinal points, and the Khafre's east and west lines are perfectly parallel. Since the pyramid builders were probably more advanced than us on construction, I think they could have built the pyramids in a way similar to what we do now. Here are some architectural drawings of modern building designs. We can see that the plans are mostly drawn according to cardinal points, the four main compass directions, north, east, south, and west, with north towards the top of the drawings. This is the easiest and most common way to do architectural drawings and constructions today. So maybe the ancient architects and engineers did the same thing. A structure that matches to the cardinal points is the easiest to draw and build. Now, let's talk about the mathematical claims and star alignments of the Great Pyramid. We are told that the Great Pyramid encodes so many important numbers and alignments, and a structure containing this much information can be something so mundane like a mind-wave storage, isn't it? Let's check out some of the most famous claims and see if they are accurate. 1. Pi. The pyramid base length divided by height and multiplied by 2 gives pi. Comparing to the true value of pi, the number is pretty close, but not the same. The pyramid builders were technologically advanced more so than us. If they wanted to exhibit their mathematical expertise, why didn't they just make the number exactly equal to pi? I'm also curious why multiply by 2? Where did that 2 come from? I hope someone can explain that. 2. The golden ratio. The slant height of a face of the pyramid divided by 1/2 of the length of the base gives pi, the golden ratio. Interestingly, now the calculation considered the Great Pyramid as a 4-sided structure instead of 8-sided with concaves. Anyway, let's just go with the claim. Here is the calculation. The true value of phi is 1.61803. Very close, but not the same. Here I'll quote a study done by Walter F. Rowe, a professor of forensic sciences at the George Washington University. He selected 22 true pyramids whose heights and base dimensions can be determined with a reasonable degree of accuracy. Then Professor Rowe used these dimensions to calculate values of both pi and phi. Here are the results. Note that when he did the exercise, he used data from 1980 and the measurements might have been changed more or less. Though we can see some Egyptian pyramids also measure closely to pi and the golden ratio, but no one talks about that. It seems that any particular agreement between the calculated and true value of pi and phi is probably coincidental. Plus, we know the Great Pyramid has 8 sides instead of 4, so the golden ratio calculation is a stretch. 3. The height of the Great Pyramid multiplied by 43,200 results in the Earth's polar radius. It's said that 43,200 is not a random number, but derived from the Earth's wobble motion. The Earth wobbles on its axis at a rate of 1 degree every 72 years. This claim came from an ancient scholar Ptolemy in the 2nd century AD. With new technologies, current astronomers knew that this ancient claim is not accurate. Also, the calculation doesn't use 72, but instead multiplies by 600 to get 43,200. Where did the 600 come from? I don't know. Regardless, the Earth's polar radius is the distance from its center to the North and South poles, and equals 6,356.7523 kilometers. According to this calculation, we have 6,333 versus the true value of 6,356. Close, but still different. 4. The base perimeter of the pyramid multiplied by 43,200 equals the Earth's equatorial circumference. The base perimeter of the Great Pyramid is 921.452 meters. The equatorial circumference of Earth is about 40,075 kilometers. So we have 40,075 versus 39,807. Again, close, but not the same. 5. The distance between the Earth to the Sun matches the height of the Great Pyramid. When the Earth moves around the Sun, the distance differs. Here is the average distance between the Earth and the Sun. Comparing to the original height of the Great Pyramid, 149.6 versus 146.6. Again, not exactly the same. 6. The pyramid's latitude matches the speed of light. Here is the speed of light in a vacuum. Here are the decimal coordinates for the Great Pyramid. The latitude amazingly matches the speed of light. But what these figures don't tell us is that many lines of latitude pass through the Great Pyramid, and the one that matches the speed of light is only one of them. Additionally, this particular latitude line doesn't pass through the pyramid's peak. The numbers in this claim are expressed to 7 decimal places, which would allow you to draw about 20,000 lines with different numbers, all passing through the pyramid. On top of that, there are 4 coordinate lines that matches the speed of light. The Great Pyramid is on one of them. Are there other megalithic structures on the other 3 latitude and longitude coordinates? There are points where both the latitude and longitude would match the speed of light. Wouldn't that be an even more dramatic and significant place to create a structure like the Great Pyramid, especially where one such point is not that far from Giza? Why not build a pyramid over there? Okay, the mathematical claims about the Great Pyramid are fascinating, but it's a bit surprising to see that out of the 6 numbers I checked, 5 of them are not true matches, all seemingly close, but not the same. I doubt any math teacher will let a student pass if his or her answers are close, but not exact. The 6th number, the latitude of the pyramid, is a match for the speed of light, but is due to the result of cherry-picking a number among 20,000 lines that all pass through the pyramid. Also, the slant height and the perimeter of the 8-sided Great Pyramid would be different from the numbers we used in the calculations. Plus, arbitrary numbers like 432 were included in the computing. I wonder why these significant numbers are not shown directly but have to be computed in different ways. Can someone explain why these calculations are the way they are? It almost appears as if people are trying to read into the pyramid's dimensions by playing with various combinations of numbers until they found ways to compute these numbers to make them somehow close to a few important values. I heard people argue that maybe the pyramid's measurements are not done accurately, therefore we don't see perfect matches. First of all, these measurements of pyramids were taken by various groups of professionals with new technologies. Second, we can use the measurements of speed of light in a vacuum, the distance between the Earth and Sun, and the Earth's polar radius, but the measurements of the Great Pyramid could have flaws. I have to say that I find this argument not very convincing. Now, let's take a look at the star alignment claims. There are multiple of them, and the most well-known one is the Orion correlation theory, proposed by a researcher named Robert Bauval in the 1980s. This theory states that each of the 3 Giza pyramids were specifically positioned and oriented to present the Orion's belt. If we look closely at Bauval's overlay of the pyramid's placement and the stars of Orion's belt, we can definitely see similarities. Yet, the alignment is not perfect. On the basis of naked eye astrometry and photometry, the Orion correlation could work. Yet if we consider the fact that the pyramid builders were more advanced than we are today, then this correlation is not up to the ancient level of work. What's more, the stars in Orion's belt have moved since the pyramids were first constructed, so their relative positions would have been different back then. A Danish explorer wrote about a 4th pyramid at the Giza Plateau in the 18th century. I couldn't find much information about it, but if it's true, then the 4 pyramids wouldn't match Orion's belt. Another theory concerns the air shafts. In the 1960s, a group of Egyptologists suggested that the air shafts were actually star shafts. One of the shafts seemed to aim in the general direction of where the North Star would have been when the pyramids were constructed. The other shaft, generally, point towards Orion's belt. These 2 sections of the sky were known to be important in ancient Egyptian mythology. This theory is based on the assumption that the pyramids were built by ancient Egyptians over 4,000 years ago. I personally think the pyramids were built much earlier and not by dynastic Egyptians. Therefore, the loose alignments with the stars might not work. There are so many stars in the sky. No matter which angle or pattern we look for, we'll probably find a close enough match. Given any building, one can probably make some kind of correlation with a certain star at a certain time. because there are countless stars out there, and the distance between our planet and these stars make whatever angles or coordinates on Earth negligible. Stars move and constellations change over time. We know this to be true, and the pyramid builders probably knew that as well. Would a highly advanced civilization which built pyramids design and align their massive constructions with ever-changing star constellations? I doubt it. Okay, let's wrap this up. The mathematical correlations of the Great Pyramid seem forced or strained, as well as the star alignment claims. Again, there are many pyramids in Egypt, though most people focus on the Great Pyramid and ignore the other ones. However, there must be a fundamental connection among the pyramids, hence we shouldn't single out just one pyramid, or we might end up with a biased, over-interpreted theory. Now, does my hypothesis that the pyramids were perhaps ancient mine waste storage seem more plausible? Mining waste storage is permanently incorporated into the landscape and exerts a major impact on the environment in many ways. A highly sophisticated culture would have performed careful calculations when designing and executing a permanent mine waste storage site. Don't forget, we're just now researching cemented tailing technology for mining waste. In the following videos, I'll discuss what might have been mined on the Giza Plateau, as well as discuss the interior structures of the Great Pyramid. If you have any insights, please leave me a comment. If you like my video, please give a thumbs up and subscribe. Don't forget to hit the bell button so you'll be notified when I upload new videos. If you want to support me, my Patreon link is below. I have a wide range of topics that I want to share with you. This is Curious Being. I'm Tina. Thanks for watching and see you next time.